Hello, my name is Micaiah, and I'm a student at University of Cincinnati, Blue Ash College, and I'm currently in Physics 1051, which is General Physics 1 with Professor Stocker. For this Pencast, I'm going to do the problem on mastering physics called Prybar, which is question 3, part A. The question gives us a bit of background to begin with, and it says pry bars are usually bent into sort of an L shape. This one is shown with a pivot point for clarity. It's the pivot point there. This pry bar is sitting on a frictionless table. You are looking from above, which means you can ignore gravity. 3 forces are shown acting on the pry bar, but for various parts of this problem, some of the forces will be 0. The 3 forces are F1, F2, and F3. So for part A, the question asks, for the pry bar to be in rotational equilibrium when F3 is equal to 0 and F1 is equal to 12 newtons, what magnitude does F2 have to be? Answer numerically in newtons to 2 significant figures. Okay. So, for the pry bar to be in rotational equilibrium, the net torque has to be equal to 0. So, before we even go further, I drew out the pry bar here, and then I labeled the pivot point. F1, which is our first force, is 3 centimeters away from the pivot, and then F2 is 8 centimeters away from the pivot, and then we have F3 acting on the pry bar at a 30-degree angle. So for this problem, what you want to do is first calculate the torque of force 1. And so to do that, you use the formula. Oh, my marker's going out. Torque is equal to R times F times sine theta, where R is the distance from the point where the force acts to the pivot, F is the magnitude of the force, and you have theta, which is the angle between R and F. And you just go ahead and plug in. Force 1 is 0.03 meters from the pivot times 12 newtons, that's given to us in the problem, times sine theta, which is sine of 30 degrees, and you get torque is equal to 0.18 newtons times meters. And then to find F2, you plug in this torque that we found for the first force into the same formula to find F2, because it has to be the same in order for it to be in equilibrium. So, torque is equal to R, let me put a label here, that's F1 there, R times F2 times sine theta. 0.18
Put the charges
newtons times meters is equal to the length of F2 from the pivot is 0.08
N minus
meters.
strong base.
Alright.
So bases always
F2.
react with
And the angle will be the same.
acid.
Sine
So where are your acidic protons?
3 degrees.
That's not a proton.
And you go ahead and solve for F2.
Beta hydrogens.
And you get F2 is equal
Which
to
one gives me the major product?
4.5 newtons.
He didn't see you, so
So for the Prybar to be in rotational equilibrium when F3 is equal to 0 and F1 is equal to 12 newtons, what magnitude does F2 have to be? It has to be 4.5 newtons. And that's how I achieved my answer.
So then,
Are you sure?
Maybe he messed up.
Maybe he didn't. Maybe
He could have messed up.
extremely confused, but